Hello ma'am, this is going to be my presentation for the uh, RFID sensor from the Arduino lesson 28. So once again, I'm just using a recording from earlier since I had to go somewhere for class, so I only had barely any time to record it, so it's just a plain showcase. So here you can see the LED, and then here's the RFID key or card, and then underneath it is the RFID itself, like the sensor. And so as you can see, the card is registered, and then you can tap it to grant access. And so there you go, access allowed, and you can hear a small sound that is from the servo motor. So the servo motor basically acts as it's like a dummy for, let's say, like a lock. So usually you'd use IFRDs for security systems. So the servo motor is just like a simulation for presumable lock of some sorts. And then it's just um and so moving on. Here we have the wiring or the pinout. So for the servo motor, it's simple. It has a ground, a VCC, and then these uh, the orange wire there is connected to one of the digital input outputs. This one right here. So that's how it's getting controlled. So for the LED, it's just the same old configuration. So it uses right here. It uses these two are used for the ground and then the VCC, and then the other two is connected to the analog pins to control its output. For for the sensor itself, it once again takes a ground and a VCC, and then it takes, I think, around 5 pins. So one is for a reset button, the other four is for an SDA, SCK, and then two MSO, and then MD something. But those four are connected to these pins right here. These RFID, these input output pins, as you can see from here. So if we play it back, you can see it's connected directly to those pins, and then we have the input output right here. So yeah, that's pretty much it for the physical demonstration. So here's just uh, zoom ins for the different wiring. So we have input output, the ground, the VCC, and then we have the RFID. Alright, so let's actually move on to the code. So for the code, first here we have the libraries. We have wire, liquid crystal, this for the servo motor, these two for the RFID. We have different pin setup. So this is for reset pin, this is SS pin. This one is to set up the we have to set up this kind of object or an initializer for the MFRC. Then we have a servo motor. So here we have aux, we have card 1, flag, LED, and CNT. So we're gonna be using this in the code for the setup. We set up this, the LED as the output. We set up the LCD, the backlight, and then the RFID. Then here we go, the tap card, then the to register. We change the cursor so that we can put it on the second line, and then my servo attach, and then my servo write 0. So just initializing all of the different steps or the different tools, devices that we have um, for the little demonstration. So here for the main loop, here we have MFRC 522 dot PICC is new card present. So essentially, this just checks if there's a card, or it basically just checks for if it basically just like checks if it's actually reading something, or if there's a card present. Same thing for this. So these two are just checks to see if if the sensor is actually reading anything, so that this piece of code doesn't break. So if there's no card that is present, so it will just return, and then the loop just keeps checking until it actually picks up any RFID signal. So once it actually does pick up an RFID signal, here we have a for loop. So what this for loop does right here is, first we simply go through I, so starting from 0, and then we iterate through the size of the UID. So the reason why we want to do that is so that the moment we get a card, so we get its UID, or it's like, yeah, it's basically UID, and then we take its individual bytes and we store it in aux. So this aux right now has the exact what call that this UID here has the exact UID from the card in bytes. So this will be our way of storing the cards, I guess, like digital ID of sorts. And so if flag is 0, so flag is basically a counter just to check if this is the first time that has been registered. So if it is, then we clear the we clear the we clear the LCD card UID, so we display the UID, and then we basically for card. So card 1 is, we simply so here once again it's kind of similar to this for loop. It goes through the loop and then it copies the individual bits and stores it in card 1, and then we just display card 1 in decimal, and then we print, and then we set flag to 1 just to show that there is actually a UID that is registered in the piece of code, and then we simply clean it back up. So we run this again. So now that flag is 1, this has concluded. It runs this instead of the else case. So what happens is, if so it basically iterates through the entire, once again similar to earlier, it basically goes through the entire size. So if ever the aux the what call that the current card the what call that the current card bits is equal to any of the bits that is written in card 1, so we basically increment this counter. So the reason why we want to increment this counter is simply just as a way to basically check if the current card that we read is the same as the previous one, which as you can see here, if it's equal to the size minus by 1, so access is allowed. So we put access allowed, and then we basically order the servo motor to move a bit and then go back to its initial form, just to simulate a lock opening. And so if that's not the case, then it will just say access denied and nothing happens. And after that, we basically reset to the initial state, so tap card to access. So that's pretty much it. We basically use a series of for loops, and then taking the ID into bytes, and then storing it in different arrays or I guess bit contents, to check if the just to check if the card is the same or not. So we register a card and then we compare it with different cards, and so on and so forth. So that's pretty much it.